Hello everyone, welcome to another Math Alien video. Today we're going to talk about Buffon's needle problem. Buffon's needle problem is actually very magical in my opinion. So Buffon's needle problem is actually very simple. So you have a bunch of lines, parallel lines. I'm sorry, my drawing is very bad, but let's just imagine that they're parallel. Their distance between the parallel lines are 2 centimeters. 2, 2, 2. And now guess what we have? We have 1 centimeter needles. They're 1 centimeter. And we randomly distribute them on the sample space. So we got a needle here, 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 we got a needle here. Yeah, so they're just like randomly distributed on this area. What we're trying to ask is what's the probability that the needle intersects? So, well, that's very easy according to probability. The probability of the event is the probability of event happening under a certain condition. Uh, let's call the condition A, and then over P over A, right? This is very well known. So, given that we have let's say 1, 2, 3, 4, 5, 6. Given we have 6 needles, and then we have 1, 2, and 3 of them intersected, we can say it's half the chance, right? Well, not exactly, because this is not an accurate result because the trial is very small. If we try it multiple times, we will get a very magical answer. Well, let's try to prove it mathematically. So, let's draw some lines again. This time we're only drawing 2. So, let's label. It's very important to label stuff. So first of all, this is 2 centimeters. We have a 1 centimeter needle, right? 1 centimeter, 1 cm. And then let's see what it takes for a needle to intersect a point. So basically, we only want to look at the midpoint, right? So we want to look at the midpoint. The midpoint, we want to figure out the distance between the midpoint and the closest side. So let's draw a line real quick. So this separates the parallel lines into 2 parts. Each part is 1 centimeter. The midpoints like of everything would be between any of this region, right? It's equal chances up or down or in the middle. So we got some random points, right? So we call the distance between the point and we call the distance between the midpoint and the closest side D. Let's see the range of D. So the minimum you can get is when the midpoint is on the line. So it's 100% intersecting, right? That's one possibility. Another possibility is it falls right into the middle. So the range of D, so D is between 0 and 1, inclusive. Right? That's D. So this is the first condition we want to look at. The second condition we want to look like is that it's at the angle of something. So we have a 1 centimeter needle here, for example. It can go many ways. It can go like this way, right? It can go this way. The thing we want to do is we want to draw a horizontal line here, here, and we want to find out the angle that it makes with its horizontal line. So example, this is theta. We want to call the angles theta, right? In this situation, the angles is theta. This theta is very close to 90 degrees, right? In this position, we have another theta. By the way, like, even if you measure this theta, it doesn't really matter. In trigonometry, there's a very famous rule. I hope you guys know. Sine 180 degrees. In math, in radians, we call 180 degrees pi. So theta minus pi pi minus theta is equal to sine theta. This is a very important identity you guys should know. So yeah, so that's part of it. Uh, okay, we're moving on to the next part. So how do we define a point intersecting? So we have a midpoint. Uh, we we have a length. We have the distance from the nearest intersecting line D, and we have an angle theta, which is this one. Yep, we have theta. Okay, so we know the length of the whole thing is 1 centimeter. So the length of half of it will be half, right? Uh, Now let's see. What we really want to compare is this. The length of this, according to trigonometry, this is half. This is pointing at it, so it's half sine theta. Half sine theta, right? If it's not intersecting, D must be greater. If it's not, let's say not. In this situation, we see it's clearly not because the line's on top of it, right? If it's not, D must be greater than half sine theta. Okay, so if we know if it's not, then we know what it is. So if it is intersecting, D. Sorry, you kind of used the wrong color. D must be less than or equal to half sine theta. Okay, that seems very very logical. And now we gotta plot it on. So we know D. We can put D as an axis. So here. So we have some angles theta. This is So we have some angles theta here, and then we have D. So D is obviously between 0 to 1. And then since the angles, we really want to consider just like acute to right angles, we want to start from 0 to 90 degrees. In 90 degrees, in radians, we call it pi over 2, right? And now we want to sketch out the graph D is less than half sine theta. So as we know, the sine wave is like this. So it starts off at 0, peaks at 1, goes down again, something like that. In this position, it's half sine theta, so its peak is at half. So in this position, this is 1, we can put it as half. It should look something like this. So 45 degrees. Let's think. So yeah. Be something like this, right? And if it's less than or equal to, we want to solve the area under this. And then the whole sample is basically the whole thing of the graph, whole area of the graph, right? That's quite straightforward. And the area of the graph is very intuitive. It's half times 1, pi over 2 times 1, which is just pi over 2 total. Total is pi over 2, right? How do we solve for the area of the green? Okay, according to calculus, we can actually use it. So first of all, we have the integral from 0 to pi over 2, and then it's half sine theta d theta. This is how you solve the integral, how to solve the area. This is called integrals, and in order to find integrals, we want to find the original function. Let's recall. What function? So what gives the derivative of sine x? As we know, the derivative of cosine theta is sine theta, right? Negative sine theta. So automatically, half negative half cosine theta. It's great. Here is simply gonna equal to half sine theta. Okay, now it's very simple. We basically minus the upper bound and the lower bound. So what is negative half cosine pi 0, that's simply negative 1 over 2. That's the lower bound. How about the upper bound? Half cosine 0. Cosine pi over 2. That's 0. That's equal to 0. So, because cosine pi negative 2, this is 0. So, the whole thing is 0. So, upper bound minus lower bound, which is equal to half. So, area is half, right? Half. And eventually, so the green area divided by the total area, which is going to be equal to half divided by pi over 2, which is equal to 1 over pi. The Buffon's experiment is like very powerful. If you actually calculate the probability, the answer is actually this 1 over pi. It's very like intuitive. It's very surprising. I feel like it's a very nice problem. I hope you learned something today. Thanks so much.